Hello everyone. Currently I am pursuing second BTech in the stream of Computer Science and Engineering in Srinivasa Ramanujan Institute of Technology. Today I am going to explain you about the topic optimistic concurrency protocols. Welcome to this detailed presentation on optimistic concurrency protocols. We will explore how these protocols are efficient alternative to traditional locking mechanism and maintaining data integrity in highly concurrent environment. The concurrency challenge in modern systems. In today's complex digital landscape, numerous users and automated processes frequently attempt to access and modify the same datasets simultaneously. This concurrent access presents a significant risk to data consistency. Coming to first one, simultaneous access. Multiple users or systems often need to read and update shared data points. Coming to potential conflicts, without stringent control mechanisms, this concurrency can lead to critical issues such as lost updates where one change overrides another or retrieval of inconsistent data. Coming to next one, the need or for robust control. Effective concurrency control is essential for ensuring both the correctness and reliability of data in any transactional system. Pessimistic versus optimistic concurrency. Two core approaches. Pessimistic locking means strict control. This traditional approach assumes that conflicts are highly probable. It involves applying locks to data resources before a transaction begins, effectively blocking all other concurrent operations until the current transaction is completed or rolled back. While ensuring integrity, it can drastically reduce system throughput under high contention. Coming to optimistic concurrency, that means trust and verify. Optimistic concurrency control operates on the assumption that conflicts are rare. It allows transactions to proceed freely without acquiring logs. The system only checks for conflicts immediately before committing the changes. This improves performance but requires a mechanism for conflict detection and resolution. Defining optimistic concurrency control. Optimistic concurrency control is a method that maximizes parallelism by delaying conflict checking to the very last moment. This makes it particularly effective in environments where read operations far outnumber write operations. Transactions are allowed to perform their operations freely on local copies of the data. Only during the commit phase does the system validate if the data read has been modified by other concurrent transactions. No locking. Resources are not locked during the transaction's execution. Validation point. Conflict detection occurs just prior to committing the changes. Conflict resolution. If a conflict is detected during validation, the system aborts the current transaction and usually initiates a retry mechanism, ensuring data consistency. This concept was formally introduced by H.T. Kung and J.T. Robinson in 1979, proving its foundational role in modern database. The three-phase optimistic concurrency control workflow. The operation of an optimistic concurrency control protocol is neatly divided into three distinct and sequential phases for every transaction. Coming to first transaction read phase. The transaction reads the required data items. All modifications are made to a private local copy or temporary workspace. Crucially, no locks are held during this phase. Coming to second transaction validation phase. Before committing, the system checks if any other committed transaction has modified the data set the current transaction read or wrote to. This is the moment of truth for conflict detection. Right phase. Commit or rollback. If validation is successful, no conflict. The changes are made permanent in the database and the transaction commits. If a conflict is found, the transaction is rolled and back must be restarted. Business case for optimistic concurrency. Optimistic concurrency is not universally appropriate, but it offers significant advantages in specific environments, leading to higher performance and better user experience. Coming to first one, low contention efficiency. OCC is ideal when the probability of two transactions conflicting is low. In such scenarios, the overhead of pessimistic locking, which slows down all transactions, is completely avoided. Coming to second one, superior throughput. By eliminating waiting times associated with locks, optimistic concurrency control op- significantly increases the potential throughput transactions per second of the entire system, allowing more work to be processed concurrently. Coming to third one, web scalability. Many modern web applications, particularly those utilizing stateless HTTP protocols, find traditional locking difficult to manage. Optimistic control concurrency is natural suited for these distributed, highly scalable and often read heavy architectures. Real world application. E-commerce inventory management. Optimistic concurrency is crucial for ensuring accurate stock levels during high traffic sales events like festival shopping seasons where multiple users are vying for the same limited items. The scenario: two customers, customer A and customer B, both attempt to purchase the last unit of a popular item simultaneously. Optimistic control concurrency in action. Both transactions proceed. Reading the stock quantity, save 1. The processes the order locally without locking the stock record. Validation. When customer A commits, the system verifies the stock record version is unchanged and decrements stock to 0. When customer B attempts to commit moments later, the validation fails because customer A already changed the stock version. Resolution. Customer B's transaction is aborted and restarted, which upon reading the new stock level informs the customer the item is out of stock. This ensures no overselling and minimal delay of the successful buyer. Implementing optimistic concurrency control, version numbers and timestamps. The core mechanism for implementing optimistic concurrency control involves associating a unique identifier with the data record that changes every time the record is updated. This allows the system to detect stale data easily. Coming to first one, version number tracking. A common approach is adding a version column, an integer, to the database table. When a record is fetched, its current version is also retrieved. The update query is then unconditional, only executing if the current database version matches the version retrieved earlier. If it does not match, a conflict is raised. Coming to second one, timestamp based validation. Alternatively, a last updated timestamp can be used. During validation, the system checks if the data record's timestamp has changed since the transaction's read phase. Timestamps must be handled carefully to ensure they are monotonically increasing and accurately reflect modification order. Handling conflicts gracefully. While optimistic concurrency control is about efficiency, its success hinges on how effectively it manages. In inevitable conflicts, conflict resolution should be transparent to the system and informative to the user where necessary. Coming to first one, automatic transaction retry. For machine to machine interactions or short, simple transactions, the application can be configured to automatically roll back the failed transaction and immediately restart it. This retry loop continues until success or a maximum attempt limit is reached. Coming to second one, user notification and manual resolution. For long running or complex user interactions, for example, editing a lengthy document, users must be notified of the conflict. The application may display the conflicting changes and prompt the user to merge or choose which version to save and preventing data loss. Coming to third one, Framework support. Many modern development frameworks and platforms such as Ruby on Rails, Spring Boot, and specific ORMs offer built-in support for optimistic concurrency control, often via automatic version number management, simplifying implementation significantly. Future proofing data integrity. Coming to the conclusion, embracing optimistic concurrency for scalable systems. Optimistic concurrency control represents a paradigm shift from cautious locking to efficient, highly parallel processing by embracing a commit and verify strategy. Optimistic concurrency control provides the best path forward for systems designed to handle massive scale and distributed operations. Key takeaways. Optimistic concurrency control balance high performance and stringent data integrity, making it the technique of choice for high read, low conflict, scalable application environments. If your system prioritizes responsiveness and throughput in an environment where conflicts are infrequent, evaluating and implementing optimistic concurrency control is a vital step toward building truly responsive and scalable applications. Thank you. I hope this presentation has provided valuable insights into optimistic concurrency protocols. Thank you for your attention.